Section 6.3, solving systems using the elimination method. So to eliminate something means to get rid of it, right? So the elimination method is going to be used to solve a systems of equations just as we use the substitution method and the graphing method. But in this case, what you do is you eliminate a variable, and you do this by adding or subtracting both of your equations together in order to get rid of something. So if we take a look at example 1, 2x plus 5y equals 17, and 6x minus 5y equals negative 9. If you were to add straight down, what would happen? Let's take a look. So if you add these two equations together, now obviously you can only add the like terms together. So if we look here, it's already lined up perfectly. We get 2x plus 6x. Well, this leaves us with 8x, right? Then we have 5y minus 5y. That gives us 0y, which cancels. And that's exactly what we want. So when we're using the elimination method, we want to look for a term where if we add our two together, they're going to cancel out. So we now just have that 8x equals, and 17 minus 9 gives us 8. Now I can solve for what x. I have now an equation that's 8x equals 8. Divide by 8, divide by 8, and we're left with x equals 1. So in order to find what y is, we just have to substitute x into our original equation, either one. So let's just use this 2x plus 5y equation because it's first. Equals 17. I'm going to substitute x as 1. So we get 2 times 1 plus 5y equals 17. 2 times 1 is 2. So we can subtract 2 from everywhere. And we're left with 5y equals 15. Divide by 5, divide by 5. Y equals 3. So what that tells us is that when x is 1, y is 3. And your system has a solution at 1, 3. So this next one, you're going to do the same exact thing. And again, it's already set up perfect for you. You're going to add your two equations together, and your 6y's should cancel. So number 2, we have a word problem. What it's going to ask us to do is create a system of equations and then eliminate one of your variables, okay? So basically what happens here is it says that a theater club sells 101 tickets to its first play. A student ticket costs $1, an adult ticket costs $2.50, and the total ticket sales are $164. How many student tickets were sold? So let's define our variables. Let's say that A, our number of adult tickets, ticks. And let's say S are the number of student tickets. Okay? So we're going to use that information to create our systems of equations. So the first equation we're going to write is about the number of tickets. So we know that we're going to have A, adult tickets, plus S, student tickets, equals 101 total. Now the next equation has to do with money. So we know adult tickets are $2.50 each, so we have 2.5A plus S. S tickets, student tickets are $1 each, so we have 1S, which is just S. And the total amount that was sold was 164. So if we look right here, we want to identify the variable that might be the best to eliminate. So it looks like if I do S plus S, I'm not going to get rid of them. But what if we multiply -1 by everything in this second equation? Now remember, it's okay to do something to the equation if you do it everywhere. So if we rewrite this equation up here, we are left with A plus S equals 101. And then we have -2.5A minus S equals -164. And that's okay to do. It didn't change the value of anything. It just manipulated it so we could get what we want. So this is like a 1A right here. If we have 1 minus 2.5, we're left with a -1.5A, right? My S's cancel, and then we have 101 minus 164, which is -63. If you divide by 1.5, divide by -1.5, you're left with that A equals 42. That means out of the 101 tickets that were sold, 42 of them were the adult tickets. So if we want to find out how many student tickets there were, I'm going to take this first equation and plug in how many adult tickets we had. Leave the student tickets blank because that's what we're trying to find. And we know the total is 101. So if we take away 42, we're left with the number of student tickets being 59. So you see how we eliminated this S variable? That's exactly what we wanted to do. So now we were left with we'll say number of student tickets was 59. Okay? I want you guys to try this pink problem on your own. It's about washing cars and trucks, and it talks about the amount of minutes and number of vehicles. So those are the two equations you're writing. So next up, it is asking us to find the solution of the system, and it's telling us to use the elimination method, okay? So we need to decide which equation which variable we want to eliminate. So when I look at my x's and my y's, my i's go directly to my y's because I have a 15 and a 5. I can easily get 5 to be 15, right? I just have to multiply it by 3. It's harder for me to multiply 2 by anything to get to 7. So what we're going to do is multiply this entire equation by 3, and we're going to rewrite our entire system over here. So we're left with 2x plus 15y, I'm not changing that, equals negative 32. And then when I multiply by 3 by everything, I'm left with 21x minus 15y equals, and 17 times 3 gives me 51. So now when I add these two equations together, I get 19x, these cancel, and this equals 19. Therefore, to get x alone, I can divide by 19, and I'm left with x equals 1. Now, that's not the entire solution yet. That's part of the solution. I need the y value. So in order to find this y value again, what we want to do is use one of our original equations, and we want to plug x as 1 in there. So I'm just going to use this original yellow one because it just looks nicer to me. So I have 7x minus 5y equals 17. If I plug 1 in for x, I get 7 times 1, which is 7, minus 5y equals 17. Subtract 7 from both sides, subtract 7 from both sides, so we're left with negative 5y equals 10. If we divide by negative 5, we are left with y equals negative 2. So the answer, my solution to the system, is 1, negative 2. My x value and my y value. You're going to try the next one on your own. Went a little bit too far. Okay, so we are going to do the same thing here. So in this problem, it looks like So I have 3x plus 2y equals 1 and 4x plus 3y equals negative 2. Now in order to do this, we need to just establish a variable that we want to get rid of. So let's just talk about getting rid of our y values. So can I multiply 2 by anything to get to 3? No. Can I multiply 3 anything to get to 2? No. So we're going to have to multiply both of these equations by something. So what if I multiply 2 by 3 and 3 by 2? I'll get 6, right? So if I multiply this top equation by 3 and I multiply this bottom equation by 2, will they cancel? 3, it would be 6x plus 6x. No, so I need to give this a negative because I need to have 6y minus 6y. So if I rewrite this system, we are left with 9x, I'm distributing this 3 everywhere, plus 6y equals 3. And that yellow equation becomes negative 8x minus 6y equals a positive 4. Okay? So when we get the answer, we're gonna add down. So 9x minus 8x is just 1x. 6y minus 6y is 0 equals 3 plus 4, which is 7. So I already got my x value. I got that x equals 7. So in order to find y, let's just plug it into this yellow equation. So we have 4x plus 3 times y. Oops, I'm really sorry. We have 4 times x, which is 7, plus 3y equals negative 2. 4 times 7 is 28, plus 3y equals negative 2. So if I subtract 28 from both sides, we're going to end up with 3y equals negative 30. Divide by 3, divide by 3, y equals negative 10. Therefore, my solution is 7, negative 10. My x value was 7, my y value negative 10. I have one more problem for you guys. I know this seems like a long one, but it's really important. So this next problem is asking us, how many solutions does this system have? So, and it wants us to use the elimination method. So what we're going to do is decide which variable to get rid of. So let's just get rid of this x variable. So in order for this x to become a negative 2x, we're going to have to multiply it by negative 2. So if we rewrite our system over here, we're going to have 2x plus 6y equals 18, and then negative 2x, and then negative 2 times 3y is going to be minus 6y equals negative 2 times negative 9 is negative 18. So if we add everything together, we get 2x minus 2x, which cancels, 6y minus 6y, which cancels, which means we have 0 on the left-hand side of our equation, equals 18 minus 18, which is 0. So 0 equals 0 is an identity, which makes sense, right? 0 does equal 0, which means that this system has infinitely many solutions, which means that they are the same line. So if you got something down here that may have said 0 equals 1, this would mean that it would be no solution, which means that they're parallel lines. So you need to know if this is true, it's infinite. If it's not true, it's no solution. Have a great night.